Here you are. Oh, thank you so much, sir. Enjoy. What are you doing? Well, I was reading people comments and feedbacks about the videos and what they're gonna learn more in the next videos potentially. So I was thinking how we can address this proactively to figure out what they would love to learn in the next videos, because all these videos are for them to learn, watch, and make impact and enjoy. I have an idea about it, but not really how we can do it. So tell me, what is your idea? Well, YouTube Analytics dashboard is giving us some data and insights about the viewers. For example, how many hours each single video has been watched on what specific topic, and so many other insights. I was thinking even us can use machine learning model to predict what would be the next preferred and desired content. But I want to understand the preferences of each individual viewer, not an aggregated information. So because we might miss some minor preferences of the viewers. So that would be great, I think. I see. Then why don't you train individual machine learning model per each individual viewer of our videos? You mean one machine learning model per each individual user? But we might have we already hundreds or thousands of viewers, so you're gonna train thousands of machine learning models? Of course. You don't know that it is possible to train even thousands of machine learning models over a compute cluster in Azure Machine Learning? Just tell me how to do it. Okay, then let's go for it. Hello everyone, this is MG and welcome to another video session. Maybe in your machine learning project you have already experienced that training one specific machine learning model is not possible to predict and analyze what you're looking for. Maybe you want to have a solution that can crunch the pattern that you would like to train the model over multiple machine learning models. Let me give you an example to make it clear. Imagine that you are an owner of a brand and you have multiple branches or multiple stores. So you would like to predict the demand for your product for each individual store that is located somewhere else. Or you would like to analyze and do some predictive analytics for each individual customer that you have. And as you might know, each of those customers might have different pattern and behavior which require a separate machine learning model to get trained and do the prediction. In other industries, let's say healthcare, for precision medicine, you would like to analyze the behavior and do the prediction for each individual patient or each individual cell. And yes, you might come up with training hundreds and thousands of machine learning models. So you might question, is it really feasible to that scale to train those models and even do the inferencing for the prediction phase? And the answer is yes. And this is the video for you to check it out, how in Azure Machine Learning and using a compute cluster there, how we can train hundreds and even thousands of machine learning models in parallel and even do the prediction as well in parallel. So welcome to the video again and let's watch it together. Here's my Azure Machine Learning Workspace. If you have never seen or utilized Azure Machine Learning Studio, make sure you watch the first part of Azure MLOps video series. I'm going to actually add this on the top right side of this video. Make sure you click on it, watch it first. That is a quick introduction about Azure Machine Learning Workspace. So make sure you understand properly the platform here, and in high level you're familiar with the components in this Azure Machine Learning Studio. And then resume watching this video that I'm explaining here about many models. So again, what we are going to achieve, what is the purpose and proposed value that we're going to achieve for this session? Imagine for a specific use case, you're supposed to train hundreds or even thousands of machine learning models. Again, as an example, You want to predict the demand for specific products that you're producing in your company for each single store that you have across the world of the country. Let's say you have thousands of stores, and you cannot use one machine learning model to train all the patterns for all these stores. That wouldn't be efficient. So instead, each single store in a specific geographical location might have different patterns, different demand for product, different type of customers in that area. So it's better to dedicate a specific machine learning model for that store and individually for all the stores. Or let's say you want to train a model to predict what's going to be the power going to be generated from a wind turbine. And you might have hundreds or thousands of those wind turbines, and each wind turbine might be located in another place with a different weather condition, any factor that can affect how much power you're going to generate. So let's train one machine learning model for each wind turbine, and then we might come up with training thousands of models for each individual wind turbine. So these are just examples. I told you again, as in healthcare as well, for precision medicine, you can analyze the behavior and predictive analytics for each specific patient there. So I'm going to actually add the GitHub repository of the code that we're going to use for this video. It will be in the video description. And what I'm going to do, I have actually cloned that code to my Azure Machine Learning. I have already created a compute, so I'll show you how I did it. For creating a compute instance, you just simply click on New. And actually I clicked on compute first, and then here you just need to specify a name for your compute, and then the type of the compute that you want to have based on the number of cores RAM. I just selected the very simple and not pretty expensive or powerful one. Then you click on create. That's it. I already did one. I named it MG01 and it is running. So what I'm going to do, then afterwards, I clone the repository that contains all the codes, which I'm going to again add in the video description so you can utilize it there. So I clicked on terminal. It gave me the terminal of the Ubuntu machine that is actually running the compute instance that I created, right? So for cloning the repository, again, I will add this to the video description. That's the GitHub repo for Medi Model Accelerator. I'm cloning all the codes there, and what you will see after, under your folder, which is here mine, you will see the many models folder with all the code that you need to go through that scenario there. And I'm not going to execute it because I did before, and you can see everything is already cloned here inside my directory. So I'll close it, terminate, and now what we need to start from is setting up some specific configurations and components we need for this many model solution. You have to go through the first notebook, which is 00, set up AML Workspace. If you have watched other videos, you know that how we authenticate ourselves to this Azure Machine Workspace. So from the config file, I am connecting to this current workspace in an object that I call it WS. So whenever I want to do any interaction using Python SDK to this Azure Machine Workspace, I refer to this WS. Then what I need to do, I need to create a compute cluster. Why cluster? Remember, we want to have all these hundreds of models, let's say, or even thousands of models in parallel over multiple compute engine. So I want to have a cluster of compute machines or a cluster with multiple nodes that each of them can separately train a model in parallel for me. So I'm giving it a name. CPU is enough for me, and I'm saying that up to maximum 20 machines or nodes I want to have over this cluster, that I can use them to train my models in parallel. And I'm connecting to my workspace within the WS that I defined on the top, giving a name for my CPU cluster, and then just executing that. I did it, I executed before recording the video, and now I have a compute cluster created for me. Let's check it out. I go to compute cluster, there you go. The name that I chose in the code is there, and you can see I can provision up to maximum 20 nodes that I specified. You can also use the UI to create a cluster. You don't need to code. The same thing, you can specify the type, and then if I click on next, it will ask me the name and the maximum nodes, which was 20 for that code. And the same thing, by the end of the day, you will see the same thing that is happening here. So now the first notebook is over. What's going to be the next step? We want to do some data preparation, of course, before training all those models. Then I need to explain what is the scenario and the use case that we are going to achieve here. For this example, what we are going to do, we have the dataset coming from Azure Open Dataset, that's the called orange juice sales. We have the dataset about different brand of orange juice that has been sold with different prices in different stores. So what we are going to do, as you can see, actually we have the sales for almost close to 4,000 stores with 3 brands of the orange juice. And now what we're going to do, we want to actually achieve a solution that can help us to train many models to predict the quantity of that orange juice for a specific brand inside a specific store. So imagine if you want to use all this data to train all these models, if you just do a simple multiplication, the number of the stores multiplied by 3 because each of them has different 3 brands of orange juice. So we might come up with having almost 12,000 models to train and then even do the batch prediction. And we have the data from this date all the way to 1982. We are not going to actually train the full scale, all that 11,000 models. We will scale it down to just show you an example to just several models, but the concept would be exactly the same, just a change in the amount of the data. You can scale to up to 100,000 of models. So now we're going to prepare the data. So what I did, I installed Azure Open Dataset because the data is coming from dataset, Azure Open Dataset. Pip install, all done, and then the dataset maximum number of files that I'm gonna get is not 10, because again I don't want to use all dataset and train all those models. And here I'm specifying pull all the data from that specific orange juice cells coming from Azure ML, and then creating a directory to download the data inside that directory. After I executed this part, there you go. This folder was created for me. If I open it, let me check which one was actually the data. Yes, there you go. The data was here. You can see I have the data for almost 10 stores. Or no, actually, it is for 1, 2, 3, almost, yes, 4 stores. And for each store, you have different brands of orange juice, you can see. Let me actually open one of them to show you. You have the store number, so that number inside the name of the file is the store ID, for example, or number. And that's the starting time, the brand of that specific juice, the quantity, which this is the part that we're going to predict, the price, and the generated revenue. So we have the same thing for different stores, and for each store, 3 types of orange juice. Perfect. We downloaded a smaller sample of all that Azure Open Dataset. Now I have it accessible. So what I'm going to do, I want to split the data in 2 sets. Why? Because I want to have a portion of this data that I downloaded for training, and then I want to do batch prediction for on the top of the rest of the data set that I'm splitting. And I want to see how I can do batch prediction in parallel, because imagine you want to use several models to do the prediction, and each of them should predict for the specific type of juice or brand that has been trained for. So this is just a simple function of reading the file. If the extension is Parquet, it will use Parquet to put in the pandas. Otherwise, it will read it as CSV. The same thing when we're gonna write. So here is the place that I'm splitting the data. I'm saying that create actually 2 subfolders for me. One folder that I'm gonna put the training data after splitting, and then the inferencing data, because I'm gonna split my data, these files, to 2 portions. And then that's it. I'm going through all these files iteratively using this for loop, and then loading CSV files, and I'm saying that based on this time, split my data before and after. So before and after, I split it, then I have 2 data sets, one for training and one for inferencing. I executed this code, you can see it run properly. And what happened after? You can say I have the upload inference data and training data. For the same type of a store, you can see and the orange juice, but the portion of the data is different. Let me open one to show you. This is a store 1000 and Dominic is the juice brand name. This is for batch prediction, so I just have 19 rows. But for training of the same store and the same brand, I have almost 102 rows. Perfect. Now we have splitted the data, and now what I can do, I will upload it to the data store. Again, if you have watched that video that I told you about, you know what is data store. That's a place that I can connect to a storage on Azure. For example, here I'm connecting to the default blob storage of Azure Machine Learning to upload the data there. We're just simply saying that grab the default data store, which is like a disk in a storage account. I refer it as data store, and then I upload the data set that I splitted there. Uploading is done. Now I need to register it as a data set in data store. Here is actually the code. I'm gonna skip this because that's for the part if you don't have any data store or you want to create a new data store, you can utilize it. But I use the default data store, so I'll skip this part. And here's the place that I can register these data set as Azure ML data set, because we want to access it in my many model training pipeline. So calling dataset from Azure ML Python SDK, I'm saying that go to that data store, the default data store, and from the path that I uploaded the data, register that dataset and give it a name. That's how you can see that I have registered with the given name. And if I show you the dataset section, you will see that train and inference data is registered after I executed this code. Let's actually check it out. So I go to dataset. Where is dataset? That's here. You can see I have the data for inferencing and data for training, and it is named as a small because I didn't grab all the data. I want to have a smaller version of the dataset and the model's number that I'm going to train. All right, now this part is optional. It is just an example of telling you how you can then interact with the registered data set. You can grab it here, download it, or convert it to pandas data frame, so on and so forth. So we can just skip it. Now what we did, we prepared the data that we need for many model training. We downloaded the data from open data set. We had a quick overview of the data, then we split the data for training and then inferencing to showcase for this demo. Then what would be the next step? Now we can train the models. So there are two examples specified in this repository. If you have your custom code for training your model here, forecasting model, there's an example for this here. So if I scroll up, there's a custom script for training and forecasting the model. But for here, what I'm gonna do, there is something even more exciting. For each store or brand of the juice that I'm going to train a model, I can leverage automated machine learning in Azure ML. This is amazing because it means when I train hundreds of models for each store, I have one model. For store B, I have another model. For store C, I have another model. These models can be different. For example, the model that has been trained for store A is algorithm A type. And then the model that is trained for store B is another algorithm type, because of the fact that AutoML will automatically detect what algorithm is the best for your store for that specific use case to train the model. So when you're training hundreds or thousands of models, those models can be different based on what AutoML has chosen as the best solution for that specific store here, for example. So I'm going to use this actually. For automated ML, I open the training folder, and here is the script 02, automated machine learning, and this is my training pipeline. I'll simply start with upgrading Azure ML SDK, making sure it's compatible with the rest of the pipeline that I'm going to use. The same thing for AutoML package, and also Azure ML AutoML pipeline steps. After executing all, you can actually do them in terminal, but I just wanted to showcase in the notebook. That's why I executed and showcased here. You know that what does that mean? We are connecting to the workspace. That's it, we have it. And then we are going to create an experiment because we want to track what we are doing. So I'm giving a name, many model training pipeline for what I'm going to do with this training use case. And then remember we registered the data sets for inferencing and training. That's the time I can grab that training data set for those the stores and 10 models that we're going to create. And again, the same thing you can do for all the data set, which would be almost 12,000 models. Here we just make it as 10 to make it fast. So I grabbed the data set from the registered data set of Azure ML. Now I have access to training data. Remember we created a compute. Here we are doing the same thing, but because we created before, it is telling me that there's already one. It's not going to recreate again. So we have the compute cluster that we need for training. Now for the training section, we are going to use AutoML, and we should specify some parameters here. They have been all explained here, but I'm just quickly going through explain that for you. So the task is forecasting. I want to forecast the quantity we talked about. What is the metric that AutoML should rely on to tell you which one is the best algorithm to choose and train for each store? I'm saying that normalized root mean square. You can certainly change it based on your use case. The maximum timeout that I can specify in minute. The maximum number of iteration. Here you can see iteration is the number of the models to train. This is optional, but provides customer with greater control. Excellent. The maximum experiment timeout in hours, here we specified 1. The label or the column that we're going to predict is called quantity. For validating a model, we use cross-validation, and that's the number of the fold for cross-validation. Here is 3. And the column that is based on time is called week starting. Why? In forecasting based on time, we need to specify which column has the time information. Now, what is max horizon? Max horizon is the number of periods you would like to predict past your training data. So I'm gonna go that much past and then decide what's gonna be the future for the quantity. And we don't want to track the child runs, you can put it through if needed. Partition column names. I want to partitionize the data based on the store and the brand of that juice, because that's the way we're gonna train the models individually. So I'm gonna partition based on these two. And there you go, the maximum batch size for this pipeline, which here is determining how many training algorithms to fetch at a time for training. Here 15. I execute it. Now I have my automated machine learning settings. Scrolling down, I'm now installing the AutoML pipeline steps, and here is a place that I'm specifying the step, which is called many model. Why I'm calling that a step? Because I want to put this step inside an Azure ML pipeline. If you don't know what is Azure ML pipeline, if you don't know what is a step, make sure you watch the video that I created, which is called Azure Machine Learning Pipeline. I will add this to the right top side of this video. Click on it, watch it. There is a complete tutorial and explain that for you. But in a nutshell, pipeline is a way to orchestrate my machine learning codes. And here I just have one step, which is many model training. I put in a pipeline and trigger that pipeline. It means it will trigger this many model step as well. I gave it a name, experiment name. I am now referring to the settings that I specified here on above. Then what is the input data you want to use for training here? What is the compute cluster? We know that we defined it before. The partition, node count, the process per node you can have, and the timeout again. And that's it. I'm gonna then have the input in my data store, which is here the default data store. I ran it, and then I put this step inside an Azure Machine Learning Pipeline. Here's my step added to this workspace inside the pipeline. Then I submit this pipeline. I'm done. Now everything started working, and I was waiting for the pipeline to execute my many model training. And here's the cool part. When I go back to my registered models or the model section in Azure ML, I saw that I have 10 models almost trained for me, registered for me, and they are ready to be used for prediction. The cool thing is AutoML selected what would be the best model for that specific store and orange juice, train the model, and register it. So I have the best of the best in parallel for any individual store without doing anything manually, and very quickly, because I use clusters, so I didn't need to wait In parallel, multiple compute machines, each of them train separate models for me for the same project, but now I have precise models for each specific store or juice brand to do the forecasting, which is excellent. Coming back to the notebook, then you can register this training pipeline. Now I just trained one time, but you can do even further. What you can do, you can register this pipeline or publish it. I didn't execute that part. And then schedule this pipeline. You can say every month from that time, start actually retraining all these models for me because there's a new data coming in. Or not just based on time, based on an event, you can trigger this pipeline, training pipeline. Let's say as soon as there's a new data coming in for each store, trigger this pipeline to retrain all these models again. Awesome. Now is the time that I want to test these models with doing a batch prediction. So within the same notebook that I have for AutoML, sorry, the folder, we clicked on AutoML training, right? And if I click on, okay, let me see where it was. Now this, instead of AutoML training, I want to open AutoML forecasting. This is doing the batch prediction. There's a folder, sorry, a notebook, now this time 03, AutoML forecasting. You don't need to install it again if you did it already, so that's why I didn't execute this part. I'm connecting to the Workspace, the same thing. I need a compute cluster for doing the batch prediction because I want to do parallel run for batch prediction. I want to have multiple machines in parallel to do the prediction using each related models that we have registered, which now we have 10 models. That's why I need a cluster with maximum, let's say 20 nodes. I give it a name for this experiment. For example, here, many model forecasting pipeline. We did for the same thing for training, and now we want to do the forecasting. Now I want to load the data set that I splitted in this time, not the training data, the inferencing data. Because I registered before, I can access it through the dataset concept. And then here I am specifying what was the experiment name in training and what was the run ID for the training. How did I grab these two? If I go to the experiment, this is the training pipeline we executed, right? If I click on it, well, this is my experiment name. I copied this one, and inside each experiment I can have multiple runs. So I just had one run which was training all those models, and if I click on it, it will give me the information about this run, and then I can see the running ID. Click on it, expand this, and there you go. The run ID is here, so I copy that from here. Coming back to the notebook, I paste them here. And now, in AutoML pipeline, instead of defining training step, we are doing the same thing, but we call it inferencing step. And it's a batch inferencing, so there are different settings we need to specify. I give it a name, experiment, we define here, on actually above. That's the data set that I want to do the prediction. These are the inputs. Using a cluster with node count 2, process per count, I already explained all of them, partitioning based on these two columns that I specified, and that's what I'm going to do the prediction. I execute it. Now I put this step, inferencing, inside the pipeline, exactly the same thing that we did for training, and then I submitted. I was waiting for this to be completed, and after finishing all, I wanted to see the outcome. So I executed this code. I give it a name for the results and the outputs, and I said load all those models that we have trained and use the pipeline, which we did. The pipeline got executed and did the prediction for me, and I am pasting the first 10 rows to see how was the prediction, and you can see that was the actual quantity and that was the predicted value. So I can do the same thing. I can schedule this pipeline or publish this pipeline to schedule it to do the prediction, let's say every day, every month. The same thing, because it's a pipeline, you can publish it based on time to be scheduled or based on an event, based on the new data coming in, then you do the prediction. So what we achieved here again, we were able to use a compute cluster with multiple machines, each of them individually in parallel, train multiple models for each store to predict the quantity for that specific, let's say, orange juice. And then for the prediction, we did the same thing. Multiple machines, each of them used the dedicated machine learning model that it trained to do the prediction or the forecasting for that specific store using the models that we registered and trained them all in parallel using many model solution and plus AutoML, automatically training model for each store in parallel for what we achieved. And that's it. Alright, now you know that this is certainly possible to train even thousands of machine learning models for any specific use case. Yes, and that means we do hear you. So please make sure you're sharing your comments, suggestions, and ideas. We consider and respect them. Definitely. Stay safe, our friends, and we will meet you shortly.